Hello everyone, welcome to the video lecturing of lecture 3 of a support reaction chapter. In the example 3, a simply supported beam AB of span 4.5 meter is loaded as shown in the figure. Determine the reaction at A and B of the beam. Okay, so in this case, they have given a simply supported beam which is subjected to uniformly varying load, that is a trapezoidal load, throughout for a span of 4.5 meter. We have to find the reaction. The first basic step is to write the free body diagram. In order to make it simple, in order to make it the analysis simpler, what we have to do is we have to convert the UBL into equivalent point load. This is in terms of kilonewton per meter. The point load we have to mention in terms of kilonewton. Okay. Now, coming to the free body diagram, if you there will be a two part in the UBL. One is a rectangular part and the another one is triangular part. Okay. So if you consider the trapezoid into two parts, that is rectangle and triangle, first I will consider the rectangle part. Okay. So in order to define the force, we know that we have to mention the magnitude, we have to mention the point of application. So now coming to this conversion of UB, there will be a two part. One part is UDL, that is rectangular load, and second part is triangular. So coming to the UDL part, in order to convert the UDL into point load, what we have to do, we have to multiply the intensity with the length. Okay. So if you consider the rectangular portion, what is the length? The length is 4.5 meter. What is the height? It is 1 kilonewton per meter. Okay. So the intensity will be 4.5 is the length for which the load is acting into intensity is 1 kilonewton per meter. So it leads to 4.5 kilonewton. Now we have defined the magnitude. The direction will be, since it is acting in the downward direction, the resultant force will also act in the downward direction. Okay, so the 4.5 kilonewton will be the total magnitude of this rectangular portion. Now we have to find the point of application. In order to find the point of application, in a rectangular load or in case of UDL, it will act at, we know that the centroid will be at the center. Okay, so if you consider the center of the rectangle, that is half of the distance you have to consider. So half into total length is 4.5 meter, 0.5 into 4.5 is 2.25 meter. So it will be acting at a distance of 2.25 meter from the support A as well as from the support B. So it will act at exactly midpoint. Okay, so this will be acting at 2.25 meter. Now coming to the triangular load, this triangular portion. In order to find the intensity of the triangle, what we have to do is we have to find the area of the triangle. What is the formula for finding the area? It is half into base into height. Okay, so if you convert the triangular load into equivalent point load, the magnitude will be always equal to the area of the triangle. So what is the area of triangle? It is half into what is the base. Base is 4 meter. Base of the triangle is from this point to this point, from point A to point B. So it is 4.5 meter. And the height, if you consider the height, this end is 0. That means if you consider this end as 1 kilonewton per meter and this end as 2 kilonewton per meter, we want this distance as height. So this will be equal to the difference of these two, that is 2 minus 1. This will be equal to 1 kilonewton per meter. So height is 1 kilonewton per meter. So this will be equal to 2.25 kilonewton. So the intensity of the triangle load is 2.25 kilonewton. This is the equivalent point load system. Again, we have to mention the distance. The distance of a triangular load will be at the centroid. that is the centroid of the triangle from the hypotenuse end. This is hypotenuse end, this is opposite end. So if you consider the triangle, this will be your this is your hypotenuse. The point joining two hypotenuse, the points of the line joining the hypotenuse, if you consider this point and this point will be your hypotenuse ends. So if you consider from the hypotenuse ends along x-axis, so the distance will be around 2 by 3 of total distance. Okay. So what is the length here? The length is 4.5 meter. From this end, it is 2 by 3 of 4.5. If you consider from the opposite end, that is this end, it will be 1/3 of the distance. Okay. So I am considering from the point A, so that is 2/3 of 4.5 meter, it will be equal to 3 meter. So the distance of point load acting will be equal to 2/3 of 4.5 meter, it is equal to 3 meter. Now, the third step is to apply the equations of equilibrium in order to find the reactions. Okay, so if you apply the equations of equilibrium, I am considering the clockwise moment as positive as the sign convention. You can also consider the anti-clockwise moment as positive, but you have to mention whichever the sign convention you have adopted here, and you have to maintain the same throughout the problem. Okay, so I am considering the clockwise moment as positive. Now I am applying the equations of equilibrium. We know that we have three equations of equilibrium. Sigma m is equal to 0, sigma fy should be equal to 0, sigma fx is equal to 0. So I will apply first sigma m is equal to 0. And I am considering the clockwise moment as positive. So if you consider the 4.5 kilonewton, I have converted into point load system and I am finding the moment. Now you are finding the moment about point A. So if you consider the moment about point A, we know that moment is equal to force into perpendicular distance. What is this force? This force is 4.5 is the force, and the distance it is acting is 2.25 meter from the point A. Since we are finding about point A, the moment it is creating the clockwise moment about point A. This point is fixed. If you apply the load in the vertical direction, it will try to rotate the object in the clockwise direction. So I have taken it as positive. Okay. Next, the second load is 2.25 kilonewton is here. So again, it is acting in the clockwise direction. So plus 2.25 into distance, perpendicular distance is 3 meter. So into 3 meter. And the third load is reaction at B. So it is creating the anti-clockwise moment about point A. So you have to keep the point A as the fix and apply the load as it is. So it is creating the anti-clockwise moment. So that's why I have taken it as minus R into perpendicular distances. It is span, that is 4.5 meter. So this should be equal to 0 according to our equations of equilibrium. Now I will if you simplify this equation, you will get the reaction B as 3.75 kilonewton as the reaction. Since you have got the positive value, the assumed direction is correct. If you get the negative value, that means the reaction B is not in the, it will not be acting in the upward direction, it will be acting in the downward direction. That is the indication of negative sign. Okay, so we got the reaction at reaction B as 3.75 kilonewton. Now if you apply I got the reaction at B. Since the reaction at A does not contribute to the moment about point A, since it is passing through the point A, it doesn't have perpendicular distance. So the moment due to reaction at A is 0. So we got the reaction B as 3.75 kilonewton. Now, in order to find the reaction at A, what I will do is I will apply the second equation of equilibrium, that is sigma Fy is equal to 0, considering the forces acting upward as positive. The forces acting in the upward direction as positive. Okay. So now if you consider the sigma Fy is equal to 0. What are the forces acting? There is a reaction. There is a reaction which is acting in the upward direction. So I have considered it as positive. So plus Ra. Then we have a downward point load, which is the magnitude of is 4.5. Since it is acting in the downward direction, I have taken it as minus 4.5 because I have assumed the forces acting upward as positive. Since it is acting in the downward direction, I have taken it as minus 4.5. Okay, so the third force is 2.25 kilonewton, which is acting at a distance of 3 meters from the support A. And the another force is reaction at P, which is acting in the upward direction. So I have taken it as positive. So I have equated it to 0 as per the equations of equilibrium. Now, if we know the RB is equal to 3.75. If you substitute here and simplify that, we will get the reaction at A as 3 kilonewton. Here also, I am getting the positive value. That means my assumed direction is correct. That is, the reaction is acting in the upward direction. If you get the negative value, that means whatever the direction you have assumed, the force is acting in the opposite direction. Okay, that is the indication of negatives. Now we have to, last step is to check whether we have solved correctly or not. What we have to do, as per Newton's law, we know that for every action there is an equal and opposite reaction. What are the actions here? The applied forces are the actions. Reactions are the resistance developed in the against the action. That is the reaction. So reactions are Ra and Rb, and the actions are 4.5 kilonewton and 2.25 kilonewton. If you take the summation of action and equate it to reaction, that should be equal. So force is, if you consider the action, there is a 4.5 plus 2.25. So totally the action force is 6.75. If you look into the reaction, we have Ra is equal to 3 kilonewton, Rb is equal to 3.75 kilonewton. So total is equal to 6.75. So I have done it. So I got to know that I have done it correctly. Okay. So let's move on to next question. So in the next question, they have asked us to find the reaction, determine the reaction for a simply supported beam of span 6 meters and is subjected to loading as shown in the figure. Okay, they have given the figure. This is the given figure. This is the given figure. We have to find the reaction. Okay, now there is a beam AB which is subjected to point load, UDL as well as UVL. Okay, there are all types of load is acting on this beam. Okay, so the first step is to write the free body diagram. So I am writing the free body diagram here. I have taken the free body diagram, support A and support B. Okay, whatever the point load we have, I have retained as it is. So 4 kilonewton and 4 kilonewton, I have retained it as it is. Now you have to convert the UDL and UVL into point load. Okay, so if you consider the UDL of intensity is 2 kilonewton per meter. In order to convert it to equivalent point load, what we have to do, we have to multiply the intensity of the load with the length over it is acting. Okay, so the intensity is 2 kilonewton per meter and length for which it is acting is 1 meter. So the load is 2 into 1. 2 into 1, it is equal to 2 kilonewton. The equivalent point load is 2 kilonewton. We have to mention the distance also. So from the end C, from the starting point, it will be acting at a half of the distance. Okay, so half of the distance means it is acting over a distance of 1 meter. So this distance will be equal to 0.5 from the end C, not from the A, it is from the C. Since it is started to act from C to D, so we have to consider this distance only. So from the C, it is acting at the midpoint. Okay, so midpoint of 1 meter is 0.5 meter. So it is acting at a distance of 0.5 meter. Now, next thing, we have to convert this UVL which is in the form of a triangular load into equivalent point load. So, in order to convert the triangular load into point load, what we have to do? We have to find the area of a triangle. So, if you consider the area of the triangle, it is half into base into height. What is half into base is 3 meter, height is 2 kilonewton, right? So half into, if you convert the point load into UVL into equivalent point load, it will be 0.5 into 3 into 2. This is equal to 3 kilometer. And we have to mention the distance. From the hypotenuse end, remember always, this is your hypotenuse end. From the hypotenuse end, it will be acting at a distance of 2/3. So from the point E, it is acting at a distance of 2/3 of the span. 2/3 of the span is 2/3 of the distance is 2 by 3 into 3, which is equal to 2 meter. From the point E, it will be acting at a distance of 2 meter from the E, okay, or 1/3 from point B, 1/3 from point B. That is, from here to here, it is 1 meter. 1/3 of 3 is 1 meter. So from here to here, it is 1 meter. So 1 meter plus 2 meter, which will give 3 meter. Okay. So after writing the free body diagram, so the first step is to apply sigma MA is equal to 0, considering the clockwise moment as positive. Now, let's find the moment, summation of moment about A, and we will equate it to 0. Okay. So first, the moment due to reaction at A about A is equal to 0 because it is acting through the point A, so there won't be any moment since there is no perpendicular distance. So the moment about point A due to reaction at A is 0. Okay, so that's why I have not considered. Next, there is a 4 kilonewton force which is acting in the downward direction. So 4 into, what is the perpendicular distance? 1 meter. 4 into 1. It is creating this is your fixed point. This is your fixed point. This point load will try to rotate the object, rotate this beam in the clockwise direction. So that's why I have considered it as plus 4 into 1. Second load is this converted UDL, that is 2 kilonewton point load. So from the C end, it is acting at a distance of 0.5 meter. But we are finding the moment about A. So we have to consider the distance from A to this point load. So from A to C, it is 1 meter. From C to this point, it is 0.5 meter. So total distance is 1.5. So intensity of load is 2 kilonewton. Perpendicular distance is 1.5. So plus 2 into 1.5, since it is creating the clockwise momentum. Next, this 4 kilonewton force. What is the perpendicular distance? We have to consider the perpendicular distance from the point A. So 1 meter plus 1 meter. So 2 meter is the perpendicular distance. So 4 into 2. Okay. So again, this point load about point A, this point load will try to rotate the object. If you fix the point A, this beam will be rotated in the clockwise direction about point A. Okay, so that's why 4 into 2. Magnitude is 4 into perpendicular distance is 2. It is creating the clockwise moment. So plus 4 into 2. Next, we have a load here which is of magnitude 3 kilonewton. So what is the perpendicular distance? 1 plus 1 plus 1 is 3 meter. From the E end, from the point E to the point load, the distance is 2 meter. So 1 plus 2 plus 1 plus 1 plus 1 is 3 meter plus 2 meter is 5 meter. So what is the intensity of the load? It is 3 kilonewton. So 3 kilonewton into 5 will be the intensity. Again, it is try to rotate the object in the clockwise direction. So it is plus 3 into 5. I have taken as plus 3 into 5. Okay. Now there is a reaction at B. It is also creating the moment, but it is creating the moment in the anti-clockwise direction. So RB into total distance is 6 meter. So RB into 6, which is equal to 0. So if you simplify that, you will get the RB as 5 kilonewton. Okay. So here I have got the value as 5 kilonewton and I got the positive value. That means my assumed direction is correct. What is my assumed direction? My assumed direction is reaction is acting in the upward direction. Okay. Now the next step is to apply sigma Fy is equal to 0, considering the upward forces as positive. Okay, the forces which is acting in the upward direction should be considered as positive. Now, what are the forces acting? There is a reaction at TA. I have taken, since it is acting in the upward direction, I have taken it as RA. Then a 4 kilonewton is acting in the downward direction. So I am considering it as negative. Then minus 2 kilonewton, since it is acting in the downward direction. Again, there is a 4 kilonewton. So I have written it as minus 4. And there is a point load here, which is also acting in the downward direction. So minus 3. Then we have a reaction at point P, which is acting in the upward direction, plus RB is equal to 0. We know the value of RB as 5 kilonewton. If you apply the value of RB and simplify this, you will get the reaction A as 8 kilonewton. Here also we are getting the positive value, so it is acting in the upward direction. Now we have to, last step is to, we have to check the values. So action will be equal to reaction. What are the sigma force? What are the action forces? There is a 4 plus 2 plus 4 plus 3. So 8, 10, 13 kilonewton is the total action. What is the reaction? Reactions are RA and RB. So RA is 8 kilonewton, RB is 5 kilonewton, total is 30 kilonewton. So hence my reactions are correct. Okay. So this is about the problem number 3 and problem. Thank you.